Hi, my name is Dear Tiagi, and in this video, I'll be going over Taylor series, which is a concept you will need to know for the AP Calculus BC exam. So to start, what is a Taylor series and why do we use it? A Taylor series allows us to transform complex functions into infinite polynomials represented using series. So an example of a complex function could be like sine of x or cosine of x. So by using a Taylor series, we can convert them into infinite polynomials, which is useful for things like physics, engineering, and computer science because it allows us to estimate the values of functions using polynomials, which are generally easier to calculate than these complex functions. So the formula for a Taylor series, this is an important one. So I'll write it here. The formula for a Taylor series, f of x centered at c is equal to f n of c, so the nth derivative at c over n factorial times x minus c to the n power. And this is the Taylor series at f of x centered at c, x equals c. Maybe just c. So that's the formula for a Taylor series. There are some basic Taylor series that you should know. These are Maclaurin Taylor series. So Maclaurin series means that the c equals 0 and the Taylor series is centered at 0. So for these, you need to know what e of x is. E of x is equal to 1 plus x squared over 2 factorial plus x squared or x cubed over 3 factorial, going on to x of n factorial. That's the pattern. Cosine of x is equal to 1 minus x squared over 2 factorial plus x to the fourth 4 factorial plus, and then this goes on, and actually minus then, but it goes on with this pattern. It goes with negative 1 to the power of n times x to the power of 2n over 2n factorial. And sine of x is x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus, and this goes on until negative 1 to the power of n times x to the power of 2n plus 1 over 2n plus 1 factorial. So those are the three Maclaurin series that you need to memorize because they're helpful on multiple choice sections or on the FRQ at the exam. One more thing. So when it asks you to find a n degree Taylor series, what you're looking for is a function with terms, x terms, with terms, and the terms go up to the x to the n power. So x to the n should be highest power. So for example, let's say we're looking for the, I don't know, fourth degree Taylor polynomial of sine of x. That would be, so we represent it as p sub 4 of x, and we want the fourth degree, so x is the first degree, x cubed, or x to the third power, is the third degree, and there's no x to the fourth, so that's just our fourth degree polynomial, like so. So we just find the highest power, that's our degree Taylor series. And I think that should be it. So let's try out a couple problems and see how we do. Okay, so let's say we're given the problem. We want to estimate cosine of 0.1 using p sub 6 of x. So this one, we want to use the Maclaurin series because, again, Taylor series work the best when you're around the center. And the reason why is because let's imagine we have a function, sine of x, we'll just call it sine of x, right? The first degree Taylor polynomial will give you like a line like that. Third degree will give you something like that. Fifth will give you even closer, and it just keeps going like that, closer and closer. So we use these for values near the center. So we want to do Maclaurin of cosine of x. So the Maclaurin of cosine of x is equal to, the sixth degree of Maclaurin is equal to, again, this should be something you memorized. It should be 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the sixth, 6 factorial. And that's the Maclaurin because, again, 6 degree is the highest degree on x. So now you just plug in 0.1, and we say that it's approximating cosine of 0.1, like so, and that equals 1 minus 0.1 squared over 2 factorial plus 0.1 to the fourth power over 4 factorial minus 0.1 to the sixth power over 6 factorial. And that's our final answer. So again, the process is we find the Maclaurin series and then we just plug it in the value to estimate it. Next, let's try out this problem. Let's say that we're given we're trying to find the third degree Taylor series for sine of x about c equals pi over 6. So the center is pi over 6. So in this case, we can't use one of our memorized formulas because those only work for Maclaurin series, which are centered at 0. And since this is centered at pi over 6, we have to figure out the Taylor series using our formula. So the method I like to use for finding Taylor series where I don't know what the actual series is, like memorized before, I use a table. So what I do is I create n, f of n x, and then f of n c. In this case, c is pi over 6. So I then use this table to find my values. So we start at 0, because that's what Taylor series start at. Oh, sorry, this should be the sum. So sum of n equals 0 to infinity. So we start at 0, right? Because that's where our Taylor series starts at. So 0, the first derivative, or the 0th derivative, just sine of x. Sine of x, sine of pi over 6 is 1/2. And then we do the next one, so we do cosine of x, because that's the first derivative. Cosine of x is square root of 3 over 2. Then we do n equals 2, that's negative sine of x. Again, we're just taking the derivatives. Plug it in, we get negative 1/2. And then we do 3. 3 is negative cosine of x, which is the same thing as negative square root of 3 over 2, pi over 6. So now we have the table, we can now generate our Taylor series using the formula. So the Taylor series is equal to, so f sub 0 of c is 1/2, and then this becomes 1, this becomes 1, so just 1/2, plus square root of 3 over 2, that's our derivative, times x minus c. X minus c is x minus pi over 6 to the power of 1, which is 1, over 1 factorial, which is 1. Then we have, minus 1/2 times x minus pi over 6. This time it's to the second power because n equals 2. Over n factorial, which is 2 factorial. This one we do minus square root of 3 over 2 times x minus pi over 6 to the third power because n equals 3 over 3 factorial, and that's our third degree polynomial. So we could choose to simplify from here, but in this case, I don't think it matters. We can just leave it like this for the AP test on an FRQ. So again, yeah, the process is we create this table, we find all our values, and then we use the formula for a Taylor series to generate our polynomial. Let's do one more example. So for this one, let's say they're asking us to find the first 3 non-zero terms of e to the x times ln of x plus 1. So whenever we're given a first 3 non-zero Maclaurin, this is a Maclaurin series also. Okay, so the first thing we know is that e to the x, the Maclaurin series for that, is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus blah, blah, blah. And so see, we're only trying to find the first 3 non-zero terms, so I don't have to write that much. I'll just write this much and see how much else we need. Next, we need to find the Maclaurin series for ln of x plus 1. Because again, the idea is we're going to find e of x, we're going to find ln of x plus 1, and then we can multiply them together by just using basic algebraic multiplication. Okay, so ln of x plus 1, we don't know what that is, so we'll use a table. So we'll say n f of n x, and then f of n 0. So 0 ln of x plus 1 is just 0. Then we do 1. The derivative of that is x plus 1 to the negative 1, just 1 over x plus 1. Plug in the number, we get 1. Then we'll do 2, so we have negative x plus 1 to the negative 2. And if we plug it in, the number, we get negative 1. 3, we get 2 times x plus 1 to the negative 3. And if we plug it in this time, we'll get 2. So what we find out is that ln of x plus 1 is equal to 1 minus, or sorry, not 1, x, right? Because we're doing the first degree, so f of n of c is 1 over 1 factorial is 1 times x minus 0 to the power of 1, which is x. Then we have minus x squared over 2 factorial, then plus 2 x cubed over 3 factorial. Okay, now we want to multiply these together. So if we multiply them together, let's imagine we have a function like this. So we do 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 times x minus x squared 2 factorial plus this is just x cubed over 3 plus dot dot dot. So when we're multiplying these together, what we have to do is we just have to use the rule that we use for basic algebraic multiplication. So we do multiply x by that, so we get x. Multiply x by that, we get x squared. Multiply x by that, we get x cubed over 2 factorial. And we can stop here because we only want the first 3 non-zero terms. So we know that it's probably going to be x cubed as the non-zero term. That's going to be the max. Next, we'll go here. So we have x squared over 2. We can multiply it here. So we get minus x squared over 2. And we can multiply it here. We get minus x cubed over 2. And finally, we can do this one. So we multiply it there. We get plus x cubed over 3. And so we don't have to do any more multiplication because, again, we're looking for the first 3 non-zero terms. The first 3 non-zero terms are going to be 1, 2, and 3. Those are the first 3. There's no more non-zero terms. So we can just stop multiplying from here. Now we add them together to find our final answer. And what we get is we get x squared minus x squared over 2 is the same thing as x squared over 2. 2 factorial is the same thing as 2. So these two cancel out. And we're left with plus x cubed over 3, which is our final answer for this question. That's the first 3 non-zero terms of this expression. So again, just to reiterate what I did here, the process is for these types of questions, what we have to do is we first have to divide it. We can break it up into two pieces. We know e of x, so we write that down. Then we find the other Maclaurin series. We can use a table, or if we know it, we can just write it. And then we have to multiply using basic algebraic manipulation techniques. And then we add it together, and we get our final answer. And yeah, that's how you do a Taylor series. And these are some example Taylor series questions you might see on the calculus exam. And yeah, that's it. Thank you guys all for watching, and I'll see you guys all tomorrow. Bye.